All right, folks, what you're going to actually get today, if you've never had a trig class before, never had physics or anything like that, then your fundamental trig relationships will be new to you. But I'm sure that if you've had a type of math course, higher level math course in the past, or even your geometry or even a basic physics class, high school physics class, some of what you're about to see you'll be familiar with. What you need to know in your trig class here, these ideas, these trig functions that you're going to be learning about, they're going to be introduced to you three different ways. They're going to be introduced to you as, in terms of the location of a point on the terminal side of an angle. We'll get to that in a minute. You're going to be introduced trig functions in relation into relation to what we're going to call the unit circle later on. Unit circle is nothing more than a circle whose center is the origin and the radius of that circle is equal to 1. And there's a relationship going on there with your trig functions. And then finally, later on, we're actually saving the last introduction as the one that you're most familiar with. And that's the relationship of a ratio of sides of a right triangle. Hypotenuse over adjacent, opposite over adjacent. So those we're going to save as the last kind of like introduction definition of trig functions. What we're going to take a look at today is, given an angle in terms of what we call standard form, meaning the vertex of the angle is at the origin, you have the initial side being on the x-axis, and then we're going to rotate this terminal side so many degrees counterclockwise until we're told to stop. And then you and I are going to pick some point P on that terminal side. And we're going to take a look at the coordinates of that point P, x comma y. So in some cases x will be positive, negative. In some cases y will be positive or negative. You know, if I were just to call out this specific example, we can see that since this point P is in quadrant 2, we see that the x coordinates, since we're going to the left, x units, so think of x as kind of being a distance, but the point itself, x would be negative, and in this case, y would be positive. Okay? Also associated with this point P is this distance r from the origin. So using the distance formula that you learned in algebra, distance formula, what's nice about the distance formula here is since the one endpoint is the origin, when we throw 0 into the distance formula, it collapses, it simplifies really, really nice. You can simply say that distance r, which is the distance from the origin to that point P, is simply found by taking x squared plus y squared and taking the square root of all that. Just know that simply comes from the distance formula in algebra. Any questions so far? So if you know x and you know y, you can quickly come up with your r value. All right? Now let's actually define our 6 trig functions. The sine of an angle, and remember this angle theta, I'm starting to scribble all over my picture, but this angle theta will always be the angle starting at this terminal side, and we're going to rotate counterclockwise that many degrees. And by doing that, we're going to pick a point, some point P on the terminal side, and that point P is associated with an x, y, and an r value. So we're going to define the sine of that angle as simply being the y coordinate divided by r. Now I want you to start thinking of these sine functions as simply like any other function that you've had. Like let's say square root function. Square root function, in goes 4, out came 2. In went a real number, out came a real number. Functions like 1/2 x. In goes 10, out comes 5. These are functions like any other function. But now we're plugging in an angle in degrees, and some real number is going to come back out. So let's just say I plug in 30 degrees. You'll see later on that the sine of 30 degrees is equal to 1/2. 1/2 comes out. So it acts like a function like any other function. However, the domain will be angles, and the range, or the values coming back out, will simply be real numbers. So to find the sine of an angle, it's simply found by taking the y coordinate divided by your r value, cosine x over r, tangent y over x, and the other three, folks, are simply reciprocals of the above three. So notice that sine and cosecant, these two are nothing more than reciprocals of one another. You simply flip the fraction and you get this one down here. Likewise with these two, likewise with those two. So you really only need to know the top three, and to get the bottom three, simply form reciprocals. Guys, got any questions so far? What do you need? X, y, and r. You're always going to be given enough information with the problem to get x, y, and r. So let's take a look at some examples. It says here that the terminal side of an angle theta in standard position passes through the point 8, 15. Find all 6 trig values. So out of x, y, and r, which one don't I know? I don't have r. Since I'm told that this point is 8, 15, we know that this is a distance of 8, and we know that this is a distance of 15. I do not know r. So using the Pythagorean theorem, or using the distance formula from the earlier introduction, you can use either one, think of it either way, distance formula or Pythagorean theorem, we know that r can be found by taking the square root of 8 squared plus 15 squared. So r is equal to the square root of, help me out there, 64 plus 225. What do we get there? 289. And the square root 289 is 17. So r is now known to be 17. Once you do that little bit of algebra, then the rest is simple. Just start forming your 6 relationships. Whatever this angle is, we know that the sine of that angle, y over r, y is 15, r is 17, 15 17ths. The cosine of this angle, x over r, 8 over 17, and the tangent of this angle is y over x, 15 over 8. Now we simply start forming reciprocals. Cosecant is the reciprocal of sine. That's 17 15ths. Secant theta, which is the reciprocal of cosine, 17 over 8. And our last one, cotangent, which is the reciprocal of tangent, is 8 over 15. They simply want you to get familiar with these ratios first, and then we start learning a whole bunch of information about these trig functions later on. They can be derived, like I said, 3 different ways. We're looking at one of those 3 ways right now. We'll look at the other 2 later on. Any questions with this example? Now this same question you're going to see 2 more times, but it's just going to become a little bit more challenging each time that we take a look at it. The example says, again, we have this angle theta in standard form, so the origin, the vertex of the angle is the origin, and we have this terminal side passing through the point -3, -4. Again, find the 6 trig values. Let's plot that point first, -3, -4, as I'm going to go left 3 and then down 4. So now let's get an idea of where is this angle theta at. So I'm going to draw 2 rays. We know that that's the initial side. And then we're going to rotate the terminal side until we get to a ray that passes through that point. So the angle theta in question is this angle, just the whole way around there. That's what we're calling theta. And we know that we have this relationship between the 6 trig functions and this one point, which we now know the x-coordinate and the y-coordinate of. which is negative 3, comma, negative 4. Again, I need my r value. Like the last problem, I didn't have r. With this problem, I do not have r. So that distance from 0, 0 to, r is always going to be positive, folks. Why? Because it's always a distance from the origin. Distance is always measured in something positive. Again, we can use either Pythagorean theorem. We can look at it that way because we have a right triangle. I'm not really supposed to introduce the whole right triangle stuff to you yet. But as you all know that we have a right triangle situation here that we'll introduce later on. We're to look at it in terms of what's the distance from 0, 0 to this point using distance formula, which is r equals square root of negative 3 squared, which is 9, negative 4 squared, 16. We end up with the square root of 25, which is just 5. So my r value is 5. Now I'm ready to come up with my 6 relationships. Sine is what?
Y over R.
Y over R. What would you answer that as? Up here.
Negative 4 over 5.
Negative 4/5. Cosine, x over r. X coordinate of my point P is negative 3 over r is 5, so that's negative 3/5. Tangent, y over x. Negative 4 over negative 3, but our negatives cancel out, so that would actually be positive 4/3. Now we do reciprocals. Sine and cosecant are reciprocals. This becomes negative 5/4. Secant becomes negative 5/3. And cotangent becomes 3/4. On your online homework assignment, you'll be given the same information, and then you'll simply come up with the six trig functions, fill in the blank with the correct fractions. Please make sure you put fractions in lowest terms if you need to. Questions or concerns so far? All right, moving on. Again, another example of this, slightly worded a little bit differently. Notice here, you are not given a specific point. It says here, find the 6 trig functions of this angle theta in standard position if the terminal side is defined by this line, and also x has to be greater than or equal to 0. Now don't draw anything yet until I tell you to. Where exactly is this line, x plus 2y equals 0? Well, if I were to solve that equation for y, we would get 2y is equal to negative x. Y is equal to negative, dividing both sides by 2, y equals negative 1/2 x. Now we all know, can kind of get an idea of where that line is. It's going to pass through the origin. And slope says to go down 1 to the right 2. So can you imagine a line, right, passing through those 2 points? Something like this. However, where on this line, and you can answer quadrant 1, 2, 3, or 4, where on this line is this condition satisfied?
4.
Where my x coordinate's positive, right? That's out to the right. So out of this whole line, I'm only interested in this part of the line, right? Those points are where my x coordinates are positive. X coordinates are positive. So where is the angle in question now? Where is this actual angle theta? Well, again, we have our initial side. We're going to rotate the whole way around here. That's theta. That's the angle that we're going to come up with our 6 trig functions for. Now, I need a point. What point do I use? Folks, you can use any point on the terminal side. Luckily, I got one labeled right here that's kind of nice. But I need you to know you can choose any point. Because no matter what point I pick on that terminal side, it's the same angle. It's the same angle in question. Preview of coming attractions later on, when we start introducing the right triangle version or definition of these trig functions, if I start constructing all of these right triangles, do you see that all of those triangles will end up being similar triangles? They're going to have the same size and same angle measures, but there's going to simply be an enlargement or a reduction. So the ratio of sides is going to remain intact. Yeah, the length of the sides are going to change, but when you start forming ratios of those lengths of sides, it's all going to simplify to the same fraction. Okay? We're going to only focus on the point P version of our definitions momentarily, but just know later on, all of those triangles end up being similar triangles. So let's go back to this point. This point was what? That point P is 2, -1. There's my x and my y coordinate. Got to come up with r again. R is equal to the square root of x squared plus y squared. So r with this problem ends up being the square root of 5. Leave it square root of 5, don't change to a decimal. Let's come up with our 6 trig functions. The sine of this angle, y over r. Y is -1 over r value square root of 5. And you've been probably told and yelled and screamed at in earlier algebra classes, you can't leave a radical in the denominator, right? You have to rationalize the denominator. So we're going to multiply top and bottom by the square root of 5. So we get -√5 over 5. Again, all I did there was multiply top and bottom by the square root of 5. Let's find the other 5. Cosine x over r. That's 2 over the square root of 5. And when we rationalize, we get 2√5 over 5. Tangent is y over x. That's simply -1 over 2, or -1/2. Now we'll start doing the reciprocals. Let's go to cosecant for a minute. Now it's time to form the reciprocal, folks, of what we got for sine. Now, to eliminate some extra steps and some extra work, I would not look at this right here, even though that's the correct final answer for sine. Think about what's going to happen, right, when you take the reciprocal of that. Well, you're putting a radical now back down in the denominator that you're going to have to go ahead and rationalize, do all that. Look what happens if you start here, right, and take the reciprocal. Oh, the radical ends up going up top. So you don't really have to worry about the rationalization step. But when we take the reciprocal, we get -√5, which is what your answer would be. Take the reciprocal of cosine to get secant. I'm going to look at this one. Simply flip that one. We get √5 over 2. And we'll flip tangent to get the cotangent, and that's simply -2. So there are your 6 answers for that problem. Any concerns so far? Just ask yourself, if I'm given this problem on online homework, I kind of know enough to be dangerous about the problem at this time. Don't let me move on if you have questions. All right. Now let's take a look at special angles. What I mean by special angles, we're going to start with the quadrantal angles, the 0, the 90, the 180, and the 270. And if we use those same relationships we just read about, y over r, x over r, y over x, let's see what would happen at these special angles. Let's start with a 90-degree angle. And you all know now that I can pick, right, any point on the terminal side. So let's pick the point 0, 1. And I asked the question, what would the r value be in this case? R would be 1, because I've gone 1 unit. If I choose this point, and I ask, well, what's the distance from that point from 0, right? It's also 1. Can you start thinking what's going to happen now with your 6 trig functions? In terms of 90 degrees, sine, which would be y over r, look what happens. What's the y coordinate? 1. What's the r value? 1. So we always get 1. So the sine of 90 is 1. How about cosine of this angle? Cosine is x over r. My x coordinate will always be 0 no matter what point I pick on that terminal side. R in this case ends up being 1, so I get 0. Tangent, which is y over x, we end up with y is 1, divide by 0, undefined. Can't divide by 0. And then your other 3, right, are simply reciprocals. So what you're seeing up here in this chart I have at the top of the page, let's just focus on 90 degrees. Can you see now where these values are coming from? The sine of 90 is always 1. The cosine of 90 is 0. And because tangent is y divided by x, we're going to try to be dividing by 0, as is also the case here. Those end up being undefined. All right, and the 3 out here, folks, are reciprocals of the first 3. Now, this looks like a lot of information to have to memorize at first, unless you come up with cute techniques for organizing this up here. So here's my advice to you for coming up with a method for kind of memorizing all. This seems like a lot of information, but I want you to look at it this way. What I like to do is I think of this picture the whole way around. And the first circle that I draw will be the sine situation. Now, I just want you to think of it this way. So draw a grid and draw an XY plane. And you and I are going to start going counterclockwise this way. And I want you to think of this inner circle as being the sine relationship. And sine of 0 is 0. The sine of 90 is 1. Now we're back to 0 again. Sine of 180 is 0. And down below, sine of 270 is negative 1. So the sine function will always then keep repeating that process. Start at 0, it's going to go 0, 1, 0, negative 1. 0, 1, 0, negative 1. Every time I go around. Okay? That's the sine relationship. I remember that one. I memorize that one. 0, 1, 0, negative 1. The next circle on the outside is the cosine relationship as I go around. It starts at 1 and goes 1, 0, negative 1, 0. And then starts repeating that process. Now, a relationship coming up that I'm going to let you know of right now, because it helps with memorizing this chart, does anybody know a relationship about tangent that has to do with sine and cosine? Go back and look at your previous problems.
Tan equals sine over cosine.
Tangent ends up being the same thing as sine divided by cosine. Look at those examples that you just completed with those 3 previous problems. Let's go back to the first one that we did, where you were to come up with all 6. If you take 15/17, divide that by 8/17, look what happens. When you divide by a fraction, it's the same as multiplying by the reciprocal. So if I take 15/17, multiply that by 17/8, look what happens. I get 15/8, which was the tangent, right? So later on, we're going to emphasize that, yeah, tangent is always sine divided by cosine. In fact, I'll go ahead and look at it this way. Sine is always y over r. Cosine is always x over r. And now what happens when we take sine divided by cosine? Well, we're going to take y over r, divide that by x over r, which is the same thing as y over r times the reciprocal, r over x. What happens? R's cancel out. You get y over x, which is what the definition of a tangent is, right? So we'll just say we know that from this point on. Tangent is the same as sine divided by cosine. So back to my little wheel that I was using to come up with trig functions for the quadrantal angles. If I know the sine relationship and the cosine relationship, I can get tangent by dividing. So back to 0 degrees right here. 0 divided by 1 is 0. So the tangent of 0 is 0. So I'm simply going to take this guy divided by this guy to get this guy. So notice here I'm going to try to divide by 0, undefined. I'm going to divide by 0, undefined. With me? And then these three over here on the other side of this line are simply reciprocals. So where I did divide, okay, to get 0, when I take the reciprocal, right here I'm thinking 0 over 1. Well, over on the other side, it's going to end up being 1 divided by 0 because of reciprocating. Well, that's why I'm going to get undefined out here. I'm sorry, not for cosecant, I meant for cotangent. They have these out of order. I wish they had them in cosecant order. But where I'm taking reciprocal of the tangent, which would have been 0, the reciprocal of that will end up being undefined because I'm just flipping the location of where that 0 is happening. So the moral of the story is this. I would definitely come up with a method for remembering those two columns, and knowing those two give you all of the other ones. I mean, what's the reciprocal of 1? What's the reciprocal of 1 over 1? 1. So the reciprocal of sine, remember, is cosecant, which is way out here for some reason. That's why we're still getting 1. 1 over 1, you flip it. All right? One other caution that the textbook recommends is for the moment, make sure your calculator for these couple of sections is in degree mode and not in radian mode. Later on that'll change once you and I talk about what radian measurement is, but for the meantime we want to make sure our calculator is in degree mode, which if we turn it on and choose the mode button, you just want to make sure, as mine is not, but mine resets every time I restart the computer, you want to make sure you have degree mode selected.